Welcome to SR Pharma GYAN. So today we are going to discuss on the action potential and graded potential. In our first lecture on action potential, we have discussed about the membrane potential, resting membrane potential, electrical signal and nerve impulse. So electrical signal in nerve cell, mainly we can get two type of the electrical signal, that is the graded potential and action potential. In short, graded potential are the temporary change into the membrane voltage. That means there is a temporary change or temporary polarization from resting membrane potential. Resting membrane potential of a nerve cell is minus 70 millivolts. So there is a temporary change or the short change into the membrane potential. Whereas action potential, it is a rapid rise. If we can find that, it is a rapid rise and subsequent fall, in membrane potential across cellular membrane with characteristic pattern. Why? Because there is a depolarization followed by the repolarization. Now graded potential, it is generally considered as a short distance signal. While action potential, it is considered as a long distance signal. Now coming to the graded potential. What is graded potential? Now graded potential, we can say that it is a small deviation. From the membrane resting potential, membrane resting membrane potential that makes the membrane either polarized, more polarized. That means it is a small deviation, small depolarization, we can say that, because resting membrane potential is rises, or less polarized means hyperpolarization, because membrane potential, it is reducing from the resting membrane potential. So it is a small deviation from the membrane potential that makes the membrane either more polarized or less polarized. And this graded potential, it will occur when mechanically gated, ion channels, or ligand gated ion channels are open. Ligand gated ion channel is open or closed. So that is for the graded potential. Now from this, what we can find, that if you see that there is a small stimulus called the small depolarization. Here it is little bit more than the previous one, but again you can say that it is a graded potential. And if you find this one, the time for the graded potential, it is more. That means longer lasting depolarization. So all those things, it is considered as a depolarizing graded potential, because membrane potential is rising. And in this case, membrane potential rises and it is crossed the threshold point. So this signal, it may be sufficient to trigger the action potential, but generally these are the depolarizing potential are the graded potential, because they are not able to trigger the action potential, or they are the small deviation from the membrane potential. In other cases, some signals are there which may cause the hyperpolarization. These all are the example of the hyperpolarization. That means decrease into the membrane potential from resting membrane potential. And this may be occurs due to the activation of the some specific ion channel. So Graded potential may be two types. One is the depolarizing graded potential or hyperpolarizing graded potential. Coming to the action potential. Action potential also it is known as a nerve impulse, and mainly it is occurs due to the opening of voltage gated ion channel. Ion channel, mainly sodium and potassium. So this is the resting membrane potential. So when there is a stimulus, and if this stimulus reaching to the threshold point, which is minus 55 millivolt, then it will cause opening of voltage gated sodium channel. Now sodium are more into the extracellular space, so whenever voltage gated sodium channel it will open, sodium it will come inside, so positively charged ion is coming inside, so membrane potential rises, which is known as a depolarization, in this point there will be the starting of closing voltage gated sodium channel. In this point, in the top, which is plus 30 millivolt, now membrane potential is plus 30 millivolt inside, opening of voltage gated potassium channel, now potassium it is more in the inside, so potassium it will go out from the cell, so membrane potential is decreasing, that is known as a repolarization. So in the membrane potential there is a characteristic pattern. First it will be depolarization followed by the repolarization, and it is also known as a cell to cell communication, and it is for the long distance, this type of the signal. And also it is important that the stimulus should reach into the threshold point to open the sodium channel and to activate the action potential, or to generate the action potential. Now coming to the what are the characteristic difference between a graded potential and action potential, that we are going to discuss. Now, graded potential arises mainly in dendrite and cell body. So this is, you can find the dendrite and cell body, dendrite and cell body. So it is arises mainly in dendrite and cell bodies, whereas action potential arises at trigger zone. Trigger zone means in the axon hillock. In case of the axon hillock, that is the trigger zone. So action potential you can say that generates into the action hillock and propagate along with the axon, and it will propagate along with the axon. So that is the first difference between the graded potential and action potential. Next one, involve activation of ligand gated or mechanically gated ion channel. Already we have told that the graded potential, if we are talking about the graded potential, it will cause due to the activation of either ligand gated or mechanically gated ion channel, whereas action potential, in case of the action potential, it will cause due to the activation of voltage gated ion channel, now mainly here the sodium and potassium. So here the voltage gated ion channel, whereas in case of the graded potential it is ligand gated and mechanically gated ion channel. Next is graded potential produced by the net movement, it is nothing but the charge, net movement of sodium. So you can say that sodium, potassium, chloride or calcium. because these are also positively or negatively charged ions, that means cations or the anions. So that will be produced by the net movement of sodium, potassium, chloride or calcium across the plasma membrane, whereas in case of the action potential, it will produce by the sequential movement of the sodium and potassium, sequential movement, because whenever we have told about this type of the graph in the action potential, this phase is the depolarization, which is occurs due to the opening of voltage gated sodium channel, and this particular area, it is known as the repolarization. This is occurs due to the opening of voltage gated potassium channel. So this is produced by the sequential movement of the sodium and potassium. Next is graded potential generated by the external stimuli or by neurotransmitter released into the synapse. So the graded potential can produced by the external stimuli in sensory neurons. If we are considering the sensory neurons, this is due to the external stimuli or by neurotransmitter released into the synapse. Whereas action potential are triggered by the membrane depolarization to threshold. Because already here we have told that this is the stimuli and this is the threshold point, which is minus 55 millivolt. So if the stimuli comes to the threshold point, then it will cause the opening of voltage gated sodium channel, and this will rise into the membrane potential or depolarization. Magnitude varies with magnitude of triggering event. That means the magnitude, that means polarization, change into the membrane potential, it may be varies with magnitude of triggering event. Now here you can find that in this picture you can find that there is a different magnitude. The magnitude of you can say that graded potential, it may be the different one magnitude, but in case of the action potential, all or none membrane response. So either there will be the membrane potential or there will be no membrane potential, either yes or no. So that is all or none membrane response. Go through the difference very minutely, understand it so that you can reproduce it by your own. You can note down all the differences for your future references. Next, coming to the graded potential, it allows the communication for the short distance. Already we have told allows the communication for the short distance, but action potential allows the communication for the long distance. Amplitude or the size less than 1 millivolt to more than 50 millivolt, or you can say that up to 50 millivolt it may be there. So this is, you can say that, because magnitude is varies, but in case of the action potential, it is about 100 millivolt. How? The resting membrane potential is 70, and after the action potential, it is membrane potential, goes plus 30. So the difference is 100 millivolt. So the amplitude is 100 millivolt. Here no minimum threshold stimulus is required, as we have told their magnitude is varies, so threshold stimulus is not required. But here minimal threshold stimulus is required. The threshold point is minus 55 millivolt inside. Therefore the stimulus which is reaching to this threshold point, it is required to produce the action potential. Clear? Action potential. So these are the difference between the graded potential and action potential. Coming to the next, typically longer, ranging from several milliseconds to several minutes. So it is generally longer duration and ranging for the higher duration. It is generally shorter and ranging for 0.5 to 2 milliseconds. But here you can find that it is several milliseconds to several minutes. Now, graded potential may be polarization event or depolarizing event. That means hyperpolarizing and depolarizing, both the things can be possible, because here again telling that these are the depolarizing event, because membrane potential is rising. That's why depolarizing event. But in such cases, this is also a graded potential. Membrane potential. It is goes down compared to the resting membrane potential. Because this is the line 70 millivolt is the resting membrane potential, so it is goes down. So it may be the hyperpolarizing event or depolarizing event. Here it always consists of the depolarizing phase. It is the depolarizing phase due to the opening of sodium channel, voltage gated sodium channel opening, and followed by repolarizing event or repolarizing phase, which is occurs due to the opening of voltage gated potassium channel. So that is important. Refractory period is not present for the graded potential. For the action potential, refractory period is present. Now, what is mean by the refractory period? Whenever we are talking about the refractory period, that means in this particular time, even a strong signal or another signal cannot generate another action potential. That means action potential, it was started and it will come back into the resting condition. After coming back to the resting condition, only another action potential it will generate. So it is nothing but it will be looks like that. That means after completion of one, another action potential is generated. So in this period, no action potential is generated. That is known as a refractory period. So in case of the action potential, refractory period is present, but in case of the graded potential, refractory period is not present. Next is graded potential travel by passive spread of or electronic spread to the next membrane region, because graded potential mainly what we have told, it is the dendrite and cell body. It is generated into the dendrites and the cell body, so it is travel by the passive spread. While action potential propagation is characterized by the regeneration of new action potential at every point along with the way. That means the action potential is generated into the axon hillock and then it will be propagating through the axon. Now how it is propagating? For example, this is the action potential it will generate, then another action potential it will generate, that will stimulate the next action potential, again another action potential, like that it will be propagating the signal. So action potential propagation is characterized by regeneration of new action potential at every point along the way in the axon. Of course, in our fourth class in the series of action potential, we are going to discuss about the propagation of action potential in details. observe into the dendrite or the neuron cell of the body, already we have discussed, and observe into the axon hillock or the axon, that is the action potential. Now graded potential, it is a local phenomena. It is a local phenomena, not communicated to the next cell in the pathway. That means it will generate here, it will not going to send this signal to another neurons. It is the local phenomena. That's why we are talking that it is a local phenomena. It is a short distance. It is a short distance signal. But in case of the action potential, it may communicate it to the next cell in the pathway. It will communicate to the next cell to the pathway. That's why it is known as a long distance, clear, long distance signal, and therefore it is known as a nerve impulse. It is known as a nerve impulse. So these are the basic difference between a graded potential and action potential. So hope you have understood what are the difference between the graded potential and action potential. These are the attribution and references. So please stay connected with SR PHARMA GYAN for our upcoming videos. Thank you.